Yeah,
Okay.
let's do it.
Yeah, okay. Hello, everybody. My name is Sunil Dadi. I'm an ISA Philadelphia Section Program Chair. Welcome to this presentation. We have here Sam Russem. He's going to present us on NEC in the context of Industry 4.0 and smart manufacturing. Sam is also our board member, and he has 15 years of experience in smart manufacturing solutions. He's a VP of Business Development at Canova, right? Am I saying it right, Sam?
Yep.
Okay, sorry about that. Yeah. So, okay. So that's all from me. Jeff, would you like to add something?
Sure. I want to thank Sunil for setting this up. I want to thank our speaker, Sam, and I want to thank you, our guests, for attending today. If you're not a member of ISA, welcome. If you are a member of ISA, we're glad to have you back. I'll put a link in the chat while Sam is talking. So afterwards, if you want to join our section, if you're not already a member, we'd certainly welcome your membership. We're at 210 members now. Philadelphia is one of the stronger ISA sections in the United States. And there's a reason why. It's from people like this. We'll put something else in the chat for you. Sunil Dodi, our new program chair, recently attended the ISA Expo and Conference down in Charleston, South Carolina, and was part of a cybersecurity conference and talk there. And he's one of the nationwide experts. So it's people like us on this call that make the section strong, and we continue to grow. So we appreciate it. I'll put out one more pitch, if I may. I'll put a couple links in the chat. We're trying to recruit students. We realize that sometimes the automation profession is something that a college guidance counselor, a high school guidance counselor may not know about. So it's up to folks like us to get the word out there on the street. So when you take a look at our section, we're actively trying to recruit at Philadelphia area schools, and we cast a pretty wide net. I was at Cheney just the other day down the road here in near Westchester, Pennsylvania. We need to get the youth into our section and into our profession for continuation. And appreciate your help. If you know of anybody that's interested, pass them our way. You'll have our information here in the links. So with that, I'll turn it back over to you, Sunil. Thank you, everyone, for joining today.
Yeah, I think we can start now. Sam, do you ready?
Yeah. All right.
Okay, sounds good to me.
Yep. Let me go ahead and share my screen and let me know when you see it. I'm having a little issue. Just give me a sec. All right. Let me know when you see my MES in the era of Industry 4.0.
I do see. I think.
That's great.
Anybody has any problem, please just put in the chat.
Yep. I do think the one other logistical note that we didn't have a chance to mention there was that we are offering CEUs for this, right? So at the end of this, we'll, if you can post an email in the chat, if you're interested, we will go ahead and take your name down.
Yeah. Sorry about that. I missed that one.
Yeah, no worries. All right. So yes, thank you everybody so much for joining us today. As has been talked about a little bit, we are here to talk about MES and smart manufacturing tech in this Industry 4.0 era. So what we're going to talk about today, I'll do a quick introduction to myself. Then we'll kind of talk pretty big picture around what is MES and kind of how does that technical definition kind of apply in context, and how do we usually see these systems being used in our factories, which almost always leads to a conversation around the IT-OT divide. So we're going to talk about that a little bit. And then we'll talk a little bit more about MES and Industry 4.0, because I think that really ties into that IT-OT divide piece of things. And then we'll kind of get into more success strategies for how to do these projects and do them well and do them to a point where they get you what you were looking for, right? So really talking about adoption and change management and other success strategies there. And I do have time at the end for a little bit of Q&A. So a little bit about me first. My name is Sam Russem. I've been in the ISA for a number of years. I had a hard time figuring out exactly how long, but I am a senior member. I was a leader in the smart manufacturing and IIoT division for a while, but now I'm more focused on the food and pharmaceutical industries division and the Philadelphia chapter, where I am a board member. A little bit of my career history. As Sunil mentioned, I've been around in the manufacturing industry for about 15 years. I started at a systems integrator at Grand Tech, which is local to Philadelphia, with an office up in Allentown. I was there for 14 years, really starting as a control engineer, doing PLC and SCADA programming, and over time started doing more smart manufacturing projects myself, and then ended up running the smart manufacturing practice at Grand Tech for a number of years. A lot of my industry experience is more focused in food and beverage, materials, and renewable energy. Being with that history as an integrator, I've worked at all sorts of different industries, but those are definitely the ones where I feel most comfortable, though again, we've done a little bit of everything. Today, I work at Kanoa MES. So we make MES software that plugs into the Ignition SCADA platform. So I'm responsible for all business development for this company. And we also like to joke, I'm on loan to our engineering team to help them out for a couple of hours a week with certain application engineering and certain features and things like that, just to kind of keep technical and to make sure I've still got some chops and can practice what I preach as I go and sell this to a lot of our customers. So I'm not talking about Kanoa today. I am talking more about MES in general, but reach out to me if you're interested to learn more about that. So what is MES? I'll start with just a basic kind of Wikipedia style definition here, right? MES stands for Manufacturing Execution Systems. These are really the systems that we use in our factory to track the transformation of our product through our manufacturing process. It's supposed to provide information to various stakeholders kind of at the enterprise level and on the shop floor level to give them real-time insights and make better decisions. And it's not a control system directly, but it's working with your control systems like a SCADA system. So it's not quite in real time all the time, but it is kind of connected to other real-time systems very frequently. Also, especially since this is an ISA event, a lot of times we talk about the ISA 95 standard when we are talking about MES systems, just because it kind of helps to put them into the context of all of the other things that go on in your factory. The other term that comes up a lot as we talk about MES is MOM, or Manufacturing Operations Management. So generally speaking, manufacturing operations management is the overall body of knowledge and activities that we do to manage the operations in our plant every single day. And an MES is a manufacturing execution, as in one system, usually a piece of software that you're using as a tool to help manage those manufacturing ops. So if we're looking at ISA 95, there's a bunch of different things that it defines that are really valuable for MES systems. This Purdue style model is one of the most common, right? So if you're not familiar with this is defining different levels of your manufacturing hierarchy in business, where level 0 is this physical layer where we're actually manipulating things in the real world and sensing that data, which is then sent up and manipulated by a level 1 control system, usually the PLC or DCS layer. Then when you go up one more level, you have your supervisory control layer. This is more of your SCADA systems most of the time. Jumping up to level 4, that's your business systems. These are the things that live in your IT network and things like ERPs or PLMs that really are kind of more of the business side of what you're doing as a manufacturer. And then level 3, in that middle part, the part that I missed, right, is that MES-MOM layer, the things that ties those level 4 business systems to those level 2 supervisory systems. So this is taking a lot of your business data and then helping contextualize it and make that usable for the plant, getting other similar data from the plant, and then sending that back up to the business systems. We also use part 1 quite a bit, which is the asset hierarchy, which defines that we usually organize our assets into an enterprise, and then a site, then an area, then a line, a number of work cells with other kind of various designations within that hierarchy. But the other thing that I do like to kind of talk about is usually a lot of times when people go through ISA 95, they kind of stop after part 1, which has a lot of kind of things like this Purdue model and has those asset hierarchies. But if you're doing MES systems, it's really important to know that ISA 95 is more than that. So when you get to part 3, it gets into a lot more of these activity models that can show you a lot of the common interactions that happen between different disciplines within your plant. So usually these are divided up into production, quality, inventory, and maintenance management. And these could be really useful models, especially if you're like struggling on where to start and defining your process and understanding the requirements for your plant and what you're going to do in an MES. Really trying to walk through some of these models and understanding how you do detailed scheduling and how you define your resources and how you define when you dispatch certain schedules to certain assets can be this can be a really valuable guide to kind of help you understand the workflows. I do recommend that you use it as a guide. It doesn't mean that if you're not following a model just like this, or if you do something slightly different, that you're doing it wrong. It really is just kind of more of a good principle that you can use to help contextualize some of your operations. And there's a lot of MES software out there that is built on similar models. So if you're thinking of your plant and your production in this way, it should be easier to translate that over to software. Also, remember I mentioned earlier how MOM is kind of the overall practice, and MES is one system that might deliver that for you. Again, I've talked about another couple already in here. That's your MES might be one piece of an architecture that includes other pieces of software like a CMMS for maintenance or a WMS for your inventory. Yeah, it's just something to think about, that as we talk about these different operations we need to manage, an MES necessarily is not always the one piece of software that will manage all of that. Let's talk a little bit also about how MES means different things in different industries a lot of the time, right? So, and you've probably picked up already that it can be a little bit of a nebulous, where as to where my MES starts and where it ends. Again, it can really depend on your application, what you're trying to get out of the software and the tool. But here are two industries that I know pretty well, food and beverage and pharmaceuticals, that in my experience, think about MES very differently. So food and beverage, for example, when they're talking about an MES system, if I get a call from a food and beverage company and they say, I want an MES, they are most likely talking about a system to manage a lot of their production schedules, the effectiveness of those schedules, to track their OEE and their downtime, and then to communicate this production status to various people to try to get rid of those inefficiencies. They're all about kind of, how do I do this process and kind of get more product out the door with less time and with less defects, right? Really boosting those OEE numbers. If we switch over to something like the pharmaceutical industry, if they give me a call for an MES, usually the first thing that they're thinking about is more around serialization and traceability. So unlike, really trying to just crank out the most product as possible, pharmaceuticals have very strict rules about making sure that you're making the right thing with the right products and at the right quality every single time. And the serialization and traceability systems are really a critical piece of that. They are also usually looking for things like batch management systems and quality systems that have full e-signatures to make sure that, again, all of this data is properly validated. And again, they are validating a lot of these systems to really make sure that that product quality is at a very high level. So two different industries could both be looking for an MES, but are talking about very different use cases when they bring that up. And then they're both right. So let's go back to the food and beverage example and talk a little bit more about the types of things that you might expect an MES to do in that environment. So here's a quick 5-step process that can really kind of talk about the full life cycle of a production order in the context of MES, where step 1, we get a customer order, right? That comes in at those business systems in the ERP, right? Say, we have an order for 1 million boxes of Coca-Cola that's going out to McDonald's, right? And that's going to hit our big ERP system in our enterprise. Now, the next thing that we're going to do is we're going to take that order or parts of that order and send it to individual sites to manufacture, right? So that is an interaction between our ERP system, which got that order in the first place, and our MES system, which is our plant management for all of the orders that come in and out. So the next step is, once this data is in the MES at a specific plant, it needs to be assigned to a specific production asset to actually make the thing. So usually within the MES at the plant level, you're going and assigning that order or part of that order to one or more production lines. Then we get to everyone's favorite step, production. We need to make the stuff, right? So This is where your MES is communicating with your SCADA and your control systems. Your SCADA and controls and PLCs, those are responsible for the actual production and the manipulation of equipment and things like that in real time. The MES is tracking a lot of your critical data throughout that process. How much did I make? How much scrap did we make? Did I go down and for what reasons? Data that's probably first collected by your SCADA system, but the key KPIs of that are being sent up and captured in your MES as well. Because then in step 5, once we have finished this order, the MES realizes that we are now complete. It packages up all this data nice and neatly, and it sends that back up to the ERP to confirm, yes, I've made this order with this quantity and any other key KPIs you need, right? Maybe your enterprise systems are, maybe you have a big scrap and waste reduction initiative. So you're going to send a lot of that data back up to the ERP for further analysis too, as needed. So again, very simplified use case, but one way that a lot of MES systems are applied in their most basic kind of form. And this is a great place to start if you're doing a lot of this type of activity in Microsoft Excel today, which is probably one of the most popular MES systems in the world, we like to joke. This is a good opportunity for maybe some software to come in and automate some more of those processes. What the output of that could look like, right? So the value of this MES that kind of takes it a little bit beyond what you're going to get in your normal SCADA system is the fact that we are collecting all of this data with all this additional business context around how we're running our plant and how we're running our overall enterprise, right? So we're collecting these metrics like uptime and downtime and production counts, including the context of the order number, the product that's being run, the shift that's being run, any downtime that's happened, any scrap that's happened. And you should be able to expect some outputs like this, right? So I might understand not just my downtime, but am I having an abnormal amount of downtime in a specific shift, right? A lot of us might expect some data like this, where maybe our third shift is overnight, is less experienced and doesn't have all the support resources that a first or second shift does, and they have more downtime, right? We might be coding all of our different scrap reasons, and we want to understand our scrap by reason. Another very common one is to maybe parse out your downtime by product, right? So say we're running 2 products on this line and we have 3 different faults we're analyzing. Maybe when I run product A, that has a significantly more machine faults, and when I run product B, it's more likely that an upstream machine gets jammed up or something and I lose product, right? So might be valuable for me to understand if I have different problems in my manufacturing process, depending on the context of what I'm running. So all good examples of type of data that you should be able to expect from a well-functioning MES. So on to our next topic. Now that we have some kind of understanding of MES systems and how they work, there's a couple of times already that I've mentioned that these high-level plant systems in your MES need to talk to other systems that are outside of your plant, which means that we force the IT-OT divide. Since MES is all about putting your manufacturing data into as much context as possible, it's usually very important for us to cross this divide to get that additional business context. Also, again, if you're not familiar with the terms, OT is the operational technology layer that is usually referring to the networks and infrastructure that you have within a plant. And then IT, we all know IT, right? Information technology, but that is usually more of a business term, right? So the credentials that I might use to log into my email and that management and things like that, all IT systems, whereas my manufacturing controls OT systems. So no matter where you are in your digital transformation, this almost always causes some challenges for manufacturers, and there's a lot of good reasons why. If you're on the IT side of things, you just have a different set of priorities than we have on the OT side. On the IT business networks, we're really focused on things like cybersecurity. That is absolutely paramount. Things like our data integrity, regular patching and updates, right? Your IT groups usually really want to make sure that all of your virus protection and your operating systems and things like that are all up to date. They want to do standardization. They usually have a lot of individual customers, and having all of these different people in your enterprise, they need to standardize that as much as possible to manage it. And disaster recovery. they can have a major fault sometimes as long as they can recover the data afterwards. Switch that and compare it over to the OT side on manufacturing. There's just a different set of priorities, right? As opposed with the top one always being availability. I don't want my OT network to cause my production to go down and my entire plant becomes unproductive because of some network problem, right? So availability, absolutely paramount. Process integrity, again, very important. If something in our network is causing us to not feed product correctly, again, that's a huge problem. We also really want stable, reliable systems with minimal changes, right? A lot of us have gone into plants and seen OT equipment that maybe hasn't been patched or is running something that is out of support, but it works. So people don't want to change it, right? So again, just a different type of mentality there. OT is usually much more focused on customization as opposed to standardization, realizing that all of these different manufacturing processes that we do are very different and that your OT equipment needs to accommodate that. And then finally, fault tolerance. Yes, of course, disaster recovery is important in the case of a fault for OT, but we just don't want to have that fault in the first place. But despite those challenges, this being able to cross this divide of getting your OT and your IT systems talking together and being more familiar with one another is critical, is critical for Industry 4.0. One could say it's the whole point that you are here and you are doing Industry 4.0 and smart manufacturing to break down these data silos and get more data and information to the right people and the right systems so they can use it and make decisions, right? So if you're struggling to get your really basic data, like production requirements, like order information, like counts, if you can't get that communicating between your MES and your ERP system, how do you ever really realistically expect to get to things like cloud technology and AI and things like that if you're not even able to communicate within your own systems today? So it's a really good litmus test to see where you are in your Industry 4.0 journey. So if we're talking about that IT and OT divide, let's talk about a couple of different ways that kind of this data can commonly flow through your IT and your OT systems. So this is more of a linear model showing it's kind of closer to that Purdue model that we showed earlier where things just talk to the layer above and below it. So here we have things like our PLCs, which are all of our real-time inputs and outputs and controls. Those then have a SCADA system that both works in real time to talk to the control systems, but is more commonly working in human time as people are hitting buttons or acknowledging alarms or doing certain activities in this system. That data communicates from between the SCADA and the MES, right? So the MES is more focused on our hourly, daily, and weekly production planning and coordination. Then we cross that IT-OT divide to get things both up to ERP and I just say to kind of other Industry 4.0 tech, right? So if you have maybe say some cloud-based AI system that is looking at your faults and trying to help you try to understand that data a little bit better, yes, that could kind of bounce through your ERP, but that could also just be directly communicating with your MES at the plant. Either way, this line right here is usually where we are splitting between what is in the plant and our OT systems and our IT systems. I'll maybe mention here that there are some more use cases we're seeing where MES is getting moved up to the cloud. Depending on your network resiliency and your requirements, that is becoming more and more of a possibility. I would, especially what I've seen today, I would almost never recommend putting your SCADA in the cloud. That is a critical control system that belongs at the plant. But MES in the cloud, maybe that can work. The other model, though, that is becoming more popular in Industry 4.0 is following the Unified Namespace or UNS model. So this takes more advantage of publish and subscribe data communications and more of a distributed communication as opposed to a hierarchy. So you still have your PLC that's usually communicating in real time with your SCADA system. That doesn't break. Again, those are critical systems that really need to be able to communicate in real time. But what's happening in UNS models is you have a separate system that multiple other things in your hierarchy can both publish and subscribe to data in. And a lot of times that is called our UNS, or it is an MQTT broker, a separate server that is responsible for consolidating and modeling and then distributing all of this data. So You could probably see a couple of advantages to this, in that things don't need to always pass through a strict hierarchy to get data to where it needs to go. There is a little bit of other complexities that do come in with this model, though. But this is definitely the more modern and popular way to do things these days, because it gives you also this really nice common platform to model all of that data to make things really easy to get up to these more advanced Industry 4.0 systems. So we've seen a couple of things that an MES can do, but one important thing that I like to point out is this statistic around that 70% of MES projects fail. I tried to find the right citation for this. I think it's somewhere in a Deloitte document somewhere, but it's a pretty commonly cited statistic. 70% MES pilots fail, or fail to get past that pilot phase. So what are the success criteria that we could be looking at to try to not make ourselves a part of that statistic, and really make an MES and a smart manufacturing implementation that goes in and is successful and scales to the plant and beyond to multiple plants? So 3 categories of tips that I will give you around trying to do a successful MES implementation and leverage Industry 4.0. The first topic is going to be around technology and picking the right systems and platforms for your environment. The second is picking the right strategy to make sure that you have something that will continue to be successful and demonstrate success. And the third is all around adoption. I think kind of the untalked about thing that really leads to a lot of success and failure in these projects. So starting with technology, what types of questions do we ask to help pick the right technology? A lot of us are probably very familiar with kind of the requirements gathering process of looking at your plant and understanding how things operate and writing requirements and getting those out to vendors. But besides just those requirements, what else is important and what else do we look at? So one thing that I think has been a really interesting question for a lot of people that are looking for new smart manufacturing technology is, do you look for these and commit to these more innovative newcomers or these established giants in the industry? Because I think, again, I'm not going to kind of go through a whole bunch of names, but I think a lot of people here know what I'm talking about. There are titans of the automation and manufacturing industry that make not just MES software, but PLCs and drives and SCADA software and a whole bunch of other things too. They're probably known for being more stable and less risky, but usually come at a higher price and are not as innovative as some of the new technologies that are coming out there on the market today, right? A lot of these are acquired through acquisitions and kind of might fit into some pieces of software, but not others. But again, there is something to, and I understand the kind of desire to latch yourself onto a big company that is known to be stable and has been around for a really long time. But there is also an advantage to maybe looking at some of the newcomers in the space, right? These are usually more innovative companies, could be startups, and they usually have really cool new solutions to more specific problems, but they are going to be more risky just by their nature. Will this company be there in 20 years if this is going to be a really important part of your manufacturing process? They also tend to be more narrow in scope. They'll probably solve a couple of problems, but not have the full, complete solution that fixes everything in your factory, like some of the big guys might, just because they have such a bigger portfolio of products. Another thing that I recommend considering is the scope and the scale of what you are trying to accomplish, right? A lot of companies look for a single MES or smart manufacturing solution that will apply to all of their manufacturing sites. Sometimes that makes sense, sometimes it doesn't, right? So it can really depend on the variety that you have within your plant, within your enterprise. There are some companies, there are some huge conglomerates out there, say in the food and beverage industry, where they might have some processes that really focus on batch and others that really focus on packaging. And maybe there's very different MES solutions for each of those and different requirements behind those plants too. So there's definitely a lot of advantage to picking one platform and applying that everywhere, but that's not necessarily the answer for everybody. The other thing that I really encourage people to think about is, what is the expected lifetime of this asset? Yes, this asset is a piece of software and infrastructure, but really you're building a system, you're building a culture shift. This is going to be a system that everybody is working in every single day. It should be treated like a large asset that's going to be at your plant Probably not for 3 years, probably not for 5 years. It could be 10 years, it could be 20. How does that affect your decision making as you're trying to pick the right tech? My last note here, as you're trying to find the right technology, is make them prove it. Companies should be excited to show you their MES and their software and what it can do for you. It's probably not going to fit your requirements 100% out of the box. That is the nature of manufacturing that we all like. The secret sauce that we have is in that manufacturing process. There will be unique things there, but you should be able to see something that does fit a lot of your requirements and is done very quickly and that really establishes your confidence in the tech stack. As you are building up that confidence in the technology, doing a pilot is usually one of the most critical steps that you will do throughout this. So how do we build a pilot and build a strategy beyond that pilot that's going to make these initiatives successful? So the first thing is to pick the right process to pilot. And if there is one thing that you take out of this session, a little pet peeve of mine, it would be, please don't pick your most complicated process for your first pilot. I understand the logic behind it. It is, well, if this software and these systems can't accomplish this most complex thing, it won't be able to really satisfy all of our needs and be able to roll out at scale. But that's also stacking risk, right? You're already going into some risk by adopting this new technology and kind of going into things like the IT-OT divide. It's probably a relatively early in your Industry 4.0 process. You don't want then also to add on the risk of this extremely complex process behind that, right? So I'm not saying you need to pick the easiest one either, but you can really get into pilot paralysis if you're trying to do the hardest thing you could possibly do on day one. One of the other techniques that I've seen really valuable and important is the idea of self-funding your own digital transformation. Ideally, your early digital transformation projects are making a return that you can then apply to future digital transformation projects, right? At the same plant or as you work to scale this out over time. That works for some people. Sometimes it can take longer to get those direct returns, but that idea of like seeing success and starting to see some money come into the program and then using that to self-fund, believe me, any executive would certainly love that because they're just getting the gains and don't need to continue investing capital. One little asterisk on that, a lot of companies can't seem to figure out what it would take for one of these projects to give a return, right? So maybe you don't know what a 5% reduction in scrap means to your bottom line, or how you would even figure out if it was a 5% reduction. Instead of having that really turn you off to the idea of digital transformation because you can't justify it, I think that should really push you towards it, because these are the tools that are going to help you to measure all of those things, right? So OEE is a quick example, right? If a lot of times customers might have even an idea of how much a point of OEE might save their bottom line, but if you don't have a measurement of your baseline, how would you ever figure out if you got the gains, right? So having a lot of these smart manufacturing and MES systems can help you to justify the entire digital transformation initiative and all of the other projects that you might be trying to consider at that plant. Finally, every pilot you do should be time-bound and maybe even time-bound instead of scope-bound. So yes, at a minimum, you should have like just a target date of when you expect these projects to be done. That's just project management 101. But would it be interesting to you and your company to maybe flip that a little bit on its head and put the onus on the technology providers to say, your job here is to convince me that this is the right technology for us within 90 days. Show us everything that you can do, put your best foot forward. This is the time bound you have. Go do as much as you can and justify to us that you can do the rest. Last, but probably most important success strategy that we have is around adoption, change management, and people. So at the end of the day, even though we are going and putting in all this cool new Industry 4.0 tech, I still think that we're quite a ways away from completely removing the people from our manufacturing processes, right? So making sure that they are on board and adopting and actively supporting your digital transformation project is really valuable. And it's more than just training, right? Human resistance to technology and process changes is one of the most difficult hurdles to pass over as you're doing these projects. And it's usually not one that comes until the very end, right? If you've been going in, you're doing all the technology side, and then you deploy this to the operators, you don't want that at the very end of your project to be the time you start to get all this resistance, right? So work with these teams, talk to these people, explore where that resistance is coming from and why. And remember, most people just want to do a good job. They're not lazy. They're not trying to get out of stuff. They just want to do a good job. They want to understand what it takes to do a good job and help put things in that context. Another success strategy around people and change management is have a champion, usually per plant. You want to have one person at least that is there. They really understand what you're doing. They buy into the overall vision, and hopefully they can be a bit of a local technical expert too, in case any issues come up. So they can be a really great ambassador also to help understand problems that are happening on the floor and communicate that to the technical teams that are really designing and upgrading the software. So having those plant champions can be incredibly valuable. It can really make or break a project. Finally, create a plan for how you're going to operate differently in the future with these new tools, and make sure that you're planning for that too. So a lot of customers, again, maybe they want an OEE system, or they want to see all their downtime, or they want their traceability, but I like to kind of ask that challenge question, but how does your job change in 6 months after you've had this and gotten used to this technology? And a lot of times the answer might be something like, well, we have a shift stand-up meeting where we want to show all the metrics from the previous shifts in the previous weeks, and use that to kind of guide and coach the team for what they're about to do on their shift. Great. What's your plan to do it? Let's make sure that we're talking to those supervisors that are running those meetings and understanding the metrics that they want to present. Let's have them potentially be some of our champions. Let's work with them in their early meetings where they start to use these screens and make sure that they're using that software properly. So really envision kind of, again, how your job changes and make a plan to do it. So to put a couple of final points on this before we open up things for Q&A, MES in the era of Industry 4.0. So yes, MES technology has been around for decades, but a lot of manufacturers still don't have the software and systems they need to manage this effectively. Or maybe they do have a current system, but it's underutilized or falling short of their expectations. Industry 4.0 is changing a lot of this. It's really forcing us to have this conversation around more connected systems and how we get deeper context and put that around all of our data. And a modern MES is really a critical piece in that puzzle. So MES implementations that are going to be successful are going to bridge that IT/OT gap that manufacturers have struggled with. So keep an eye on that. And remember that a failed pilot can set you back instead of pushing you forward, right? So if you want to move forward, pick the right technology, develop a strong implementation plan that's going to work over the long term, and make sure that you're managing change effectively across both your people and your process. So with that, I'm open for questions. You can drop questions in the chat if you are feeling shy, or I believe you can also come off of mute and ask them that way too. But let's give a couple of minutes to see if people want to do something interactive. Let's see. Oh, there's already a little bit of conversation in the chat, mostly around if this is being recorded. Yes, it is. I see one comment in here. Oh, sorry, go ahead.
Oh, sorry, Sam. I just, so I think a lot of times when we think about piloting, or we think about MES and Industry 4.0, we're thinking about established facilities, or, you know, like you said, there's conglomerates who already have infrastructure. When you're starting from scratch, so let's say you've got, so as an example, I just started working for a co-man who's you know, barely a year old, and we're still just working on line control at the control layer. Where's the best place to start where you don't feel like you're drinking out of a fire hose?
Boy, that's a really good question. Yeah, let me think about that for a sec. I do think that everybody always wants to get involved early, right? And I don't think that your MES and your Industry 4.0 stack is any different. I think that they should be a part of the conversation early, and again, should be a part of that longer term vision for what this greenfield site is going to do, right? I think that if you kind of look at once this site is done and been operational, just for a year or two, what does that look like, and how do I kind of walk back from that, and what do I need to be doing now to try to realize that future again, right? But it is definitely a challenge on the MES side, right? So I feel like a lot of those control systems and SCADA systems can have very well thought out requirements documents and things like that. The MES is usually lacking there a bit, right? So it is tough to figure out everything that you're going to need for all of these plants before they're actually in operation. So it's tough. It is more of a challenge, but I do think that there is value to it, and especially it can really help to conquer maybe some of those challenges that you're going to have around some of the requirements gathering, kind of designing for something that doesn't exist yet, are kind of offset by things like some of the adoption challenges, right? You don't have people that are used to doing things a certain way and are going to potentially resist putting in a new system. This is just going to be the way it's always been. So you have a little bit of advantage there too.
Sure. That makes sense. Yeah. And I'll say, like, the biggest hurdle that I, for sure is the capital cost without being able to realize return, right? So, or demonstrate realized return. So, for us, it's how do you justify it when you really don't have things connected to begin with? So it's that's kind of where we're at now. But I think what you're saying makes a lot of sense.
Well, and the other thing I'd really recommend, Mike, around that is to not, eat the entire elephant in one bite, right? You want to start small with the things that you think are accomplishable and achievable with the information that you have, but in a platform that you're going to be able to build on, right? So maybe you really, I don't know, maybe your traceability, for example, is something that you're like, that's going to be a more complicated beast that's very process dependent. So we're going to hold off on something like traceability, and we're really going to focus on production scheduling because we know that that's something we need on day one. Great question. I'll think about that more too. That's a good one, especially because I definitely have a meeting with the Greenfield team tomorrow. Let's see. I see a question in here. Oh, and they added me in it too. Best practices related to software and edge hardware architecture. That's a really good question. I'm going to jump back to these slides here. So we talked a little bit about, kind of this very linear model versus kind of more of a UNS style model and something that's distributed over here. The times that edge devices can be used really in either type of solution, right? They could be kind of tied into PLC cabinets. You could have multiple edge devices and multiple PLC cabinets. You could have a couple kind of for certain areas or things, but yeah, I would say that edge devices really kind of come into play depending on your PLC and SCADA architecture, right? There are times that you're going to have a SCADA on site that can really kind of manage a lot of those kind of distribution of data after that. But if you don't have that centralized SCADA system yet, or if you have a really isolated system that hasn't been brought into the OT network before, edge devices are a really fantastic solution for that too. So I don't think you need to pick one or the other either. I've seen a lot of implementations where maybe a lot of data is going into a SCADA system and you're using that, but then you have some unconnected pieces of equipment too, and it's the first time you're bringing them online, and maybe those get the newer, fancier edge technologies along with them. Okay, I see a question around where do you start if you have only islands of automation and no plant-wide controls such as a SCADA? That's another really good question too. I like that one. So, because I think that you also, again, have a potential opportunity, depending on exactly what you're looking for, to skip SCADA if you really want to. So again, I would kind of, where do you want to be in 5 years? Where do you want to be when you grow up? If you do think that a plant SCADA is going to be a valuable thing for this plant and kind of what you're doing, that might be an investment that you want to make before you kind of jump into higher level digital technologies, right? Again, kind of that idea I talked about earlier, where if you can't even connect to your ERP system from the plant floor, what are you doing talking about AI, right? So if you think a SCADA is going to be important for you, maybe you focus on that first. If you're more concerned about, say, maybe you have a bunch of individual pieces of equipment that are very self-sufficient and a SCADA is not a very good application for that, you could have a really cool opportunity to take that last conversation we had about edge devices And really, instead of doing the SCADA layer, you're putting edge devices in each of those, again, PLC cabinets, sending that directly to the cloud, not getting any infrastructure on your site, and doing some of your higher level data management in there. So that would be a really good application for this more kind of UNS model. But that's one idea. If you kind of aren't ready to invest in a plant-wide controls network, but you want to dabble in the Industry 4.0 technology side of things, getting an edge device to certain pieces of equipment, getting that data to the cloud can be a great place to start. Thanks for that question, Fred. I see more stuff getting in the chat. Here's another one. What do I think about Industry 4.0 being a stepping stone to AI ML based Industry 5.0 that relies on near real-time contextualized, normalized data? Well, first of all, I think that we don't have enough companies that have actually done anything Industry 4.0 related to talk about a new Industry 5.0 thing. I think that this is all the same, right? It's all the idea that, we've gone through industrial revolutions don't happen very often, right? They're a couple 100-year events. So I do think that something like so I think that Industry 4.0 is moving from Industry 3.0, where we start to use industrial revolutions don't happen very often, right? They're a couple 100-year events. So I do think that something like so I think that Industry 4.0 is moving from Industry 3.0, where we start to use PLCs and computers to control equipment. And now Industry 4.0 is all about taking that data and getting it into the cloud and using it with more advanced computing systems to get more insights. So I philosophically think that the AI ML integration is a part of what we are talking about here. Now, when it comes to thinking about that in real time, I think that, again, there are some applications of this that I have seen already, right? So one example I've seen is that Amazon, for example, has all of these very advanced AI ML sensors for all of their conveyors and a bunch of their warehouses because, they have the infrastructure to do it and they have a ton of conveyors. So it made sense for them to invest in a product that does measure those vibration analyses in real time and get that immediately back to the teams that need them. So yeah, I think that everything that we're talking about here around crossing that IT/OT divide, getting data to the right places that need them, all a part of the Industry 4.0 or 5.0, if you want to call it that, conversation. Great. And now I see, what are some alternatives for monitoring manual stations? Where are notes in the operators? Where are the notes in the operator's hands? Yeah, so that's a good question too. And I'd say the main answer that I see to that, which is a very incomplete answer, is, oh, well, we'll just give everybody tablets, which is a cool idea. If you can actually pull that off, there is definitely, I think, something to not trying to get automated data for everything, getting something. I'd rather have something digital today than automated in a year, right? So if that means that you need to manually enter it digitally today, I think that that is a big win for a lot of manufacturers that are out there. So it could be computer terminals on the floor, it could be iPads or other tablets that people are keying data into. But yeah, I don't think that digital transformation and MES needs to always be automated. It is very okay to get those notes into operators' hands and work with them and help and use them as a stepping stone as you're getting to more automated systems. Great. Oh, okay. I have another question around image recognition. What does that mean in the context of? I'm not sure that I follow that question. Sorry.
In the context of monitoring, so there are already some solutions deployed that track the operator's movements and can identify what they're doing,
Yeah.
at least on a high level.
Yeah, I've seen some of those too. It's a neat concept. Yeah, what's the question about it, I guess?
It's kind of a reply to the previous question.
Oh, okay, got it. I'm sorry, I understand better now. Thank you. Oh, but I do have a question. I should definitely talk about this. Why MQTT? Why not OBC UA? Someone correct me if I am technically wrong on this. But I believe it's around the pub sub model of it. I do not believe that OPC UA is a publish subscribe model. It is a very good protocol that I know has been adopted by a lot of different companies. I usually see MQTT paired more synonymously with UNS because of that publish subscribe model. If you have a lot of different systems that are all posting data and then certain ones that need to subscribe to that, MQTT is this really good, very low footprint method to get a lot of that data out there. So yeah, OPC. So usually this layer here, your PLCs to your SCADAs are OPC, right? Because that's just the standard for that real-time communication. But if we're getting into bigger data pictures, then the pub sub nature of MQTT can be really helpful. I see more questions getting typed in, so I'm going to give just a second. Really appreciate all of the feedback and questions here, guys. This is great. While I'm waiting for that last question to finish getting typed in, I'm going to jump real quick over to our little thank you page. Again, I'll kind of remind you all, this has been put on by ISA's Philadelphia chapter, so really appreciate everybody's support in coming into here. And again, if you're not an ISA member today, or if you're an ISA member but not a Philadelphia chapter member, definitely reach out to Sunil, myself, Jeff, anybody who's kind of on the ISA side on the call today. We're happy to talk to you about all that. And if you were hoping to get some CEUs out of today's session, just post your email in the chat, just like Stan did, and we'll be recording all of those and doing what we can to get that out to you. All right, I have one question that I'll use to wrap it up today. PLC is usually not performance enough to run MQTT, so you push OPC to an. Oh, that's just a statement. Yes, thank you, Joseph. Correct. Yes, some PLCs don't do MQTT. That is where an edge device would very frequently come in and help you. And again, they can usually talk to those PLCs and then do the MQTT part out of it. And yes, CEU is a continuing education credit. So if you are a professional engineer or something like that, and you need to maintain a certain number of CEUs to maintain that credential, this counts. So yeah. Great.
Yeah.
Okay. All I'm getting now are CEU requests. So, but I have 7 minutes as people are still typing that. So if you have any final questions, I'm happy to do that, or just sit here and smile for another minute. Sunil, anything else that you want to throw out there and close us out, or Jeff?
Yeah, looks like there are no more questions, and it's a just wonderful presentation, Sam. Thank you so much. Perfectly addressed the the issue and the possible strategies that you could do. If I could summarize, can I say the main issue is the integration between IT and OT for smart manufacturing as a board eye level top thing. Okay, yeah. That's a wonderful presentation.
Yeah, I think it just forces the conversation in a way that a lot of companies haven't, right? Every company usually has IT, OT divide problems. It's when you try to do something like an MES system or another Industry 4.0 that like it becomes a requirement, and then kind of all the skeletons pop out of that closet.
Wonderful. Yeah. Jeff, would you like to add something? We still have
Sure.
5 minutes.
Yeah. Thank you, Sunil. And Sam, great presentation. I learned a lot. Really appreciate everybody's feedback. And again, like Sam mentioned, if you're not a member of ISA Philadelphia, we welcome your membership. Please stay tuned to your email, to our LinkedIn site, and ISA Connect to follow the next couple of programs. And I'm proud, Sam, you've earned the standard ISA coffee mug gift. So congratulations for that. That and a good self-administered pat on the back. Great job. We really appreciate the feedback and a professional level, objective presentation. We are interested, and Sunil's our program chair. We're always interested in good programs. The key is they have to be objective. We want to educate our members. We want to learn about Industry 4.0. We want to learn about wireless. We want to learn about Ethernet. We want to learn about new instrumentation, valves, etc., robotics, AI. And we've got some great speakers. We've had the benefit of that. So please keep it up, reach out, keep the communication going. And we look forward to hearing from all of you. And we'll have an update soon on our next meeting coming up. If you do check out the links I put in the website or in the chat here for the meeting, we're actively trying to recruit students. I put a couple things in there about joining our section, and we're proud of Sunil, our program chair here, for the work he did down in Charleston, South Carolina, as part of the ISA Summit and Expo. So that's it for me. Sunil, I'll turn it back over to you, sir. Thank you very much.
Yeah, that's a wonderful
Yeah.
presentation. And
one more quick thing, Sunil, is I will also maybe mention to everybody, if you do want to follow up on any of this, there's a topic that you want to explore more. I talk about this stuff a lot, so feel free to search me on LinkedIn, or I just posted my email in the chat. So if there's anything you want to talk to me about, don't be shy. I'm always happy to chat about it.
Yep, that sounds good to me, and I bet for the listeners also. Okay.
Awesome.
So thank you all for joining. I hope you definitely, learned something today. I hope, thanks to our speaker, Sam, and our section director, Jeff.
Awesome. Thanks, everybody. Really appreciate
Thanks,
you
everybody.
all.
Bye.
Yeah, appreciate it. Bye.
Thank you.
Thank you. Have a good one now.
Thank you. Bye bye.